A Doppler effect. The definition of Doppler effect is the apparent change in the observation frequency or wavelength of a wave due to the relative motion between the source and observer. Sound waves moving towards observer high frequency pitch increases and away from the observer lower frequency pitch decreases. Okay, for light wave, if that light wave is moving towards the earth, then that is a blue shift, and it is if it is moving away from the earth, then it's a red shift. Okay, so first we are going to talk about the formula that we are going for to use for Doppler effect. So Doppler effect formula formula is f naught or f observed is equal to frequency of source v over v plus minus vs. Okay, so that v is the speed of sound, whereas vs is the speed of source. So I will write everything that down here. F naught is observed frequency. Fs is source frequency, frequency. V is speed of sound, whereas Vs is speed of source. So now we will talk about the important thing, that is if source moves away, we take the positive value, and similarly if source moves towards you or the observer, that could be negative. Now we will do one example. So that example is uh, a police siren emits 800 hertz while moving away at 20 meters per second. Find observer speed. Find observer speed. Observe, sorry, frequency. So how we are going to do that question? So we have to find FO, that is FO is equal to Fs into V over V plus that is moving away, so that is plus over Vs. So what is Fs? Fs is 800 hertz. So Fs, where is Fs? One second. Fs is 800 hertz. Speed of sound is 340, and here speed of V is 340 plus speed of source is 20 meters per second, and we take it positive because it is moving away from us. So that will give us, if we simplify it, that will become simply 800 into 340 divided by 360. So we will cancel out these zeros, and that will give us 756 hertz you will hear from the observer point. Now what is redshift? So I will just talk about what is redshift. So redshift, when a galaxy moves away from the earth, its light stretches. Okay, that's why it gave us a red color, and due to that its wavelength also increases. Now, why does redshift occurs? Why does that happen? Redshift shift happens. So, as galaxy moves away, light waves become stretched. Okay, therefore wavelength will increase and frequency will decrease. Okay, now how we can calculate the redshift? How? So the formula for redshift is redshift formula. Formula is z is equal to lambda observed, that is wavelength observed, minus lambda at rest divided by lambda at rest. Okay, now we are going to do one question on that. Okay, so for example, original wavelength original wavelength is 500 nanometers. Observed wavelength is 505 nanometers. Find redshift. Find redshift. So what we are going to do? Simple solution is z is equal to lambda observed, that is 505. So original wavelength is 500 divided by 500. So that will give us z is equal to 0.01. Okay. Now we are going to discuss about Hubble Lamarc's law. That is the last thing. So that is Hubble Lamartre law. So the further away galaxy is, the faster it will moves away. Okay. So the formula for that is v is equal to h dot d, where v is recession velocity, recession velocity, h dot is Hubble constant, and d is distance. Okay. That's all about this topic. If you want to get more about that, you can take our online classes that is available.